All right, so here we're looking at factor by grouping. Now, when it comes to factor by grouping, there's several key things that we want to pay attention to. So make sure you're paying close attention to the notes and the steps on this one. And what I say might differ from what other people say. So again, if you're studying with somebody else and they have a different method and that works for you, great. But the nuts and bolts are really the same. All right, so factor by grouping is mainly characterized. It's mainly characterized by the fact that you are going to factor a four-term polynomial. And it's very crucial that we take a look at this. It's the only time you're going to factor a four-term polynomial outside of greatest common factor. Now, again, greatest common factor has to be considered for everything first, all right? So step one is always GCF, and then we take a look at the other steps depending on what we're looking at. So here, we're really going to focus in on the factor by grouping aspects. So the steps, here are the steps. Hopefully we can outline this in a way that we can just go follow through. So the first step that you're going to do is you're going to group the first two terms. So you're going to group terms 1 and 2 and 3 and 4. So you're going to group the first two terms and the second two terms. And this is where I might differ from everybody else. But here I'm going to say include the middle sign. All right, if the middle sign is negative, then you're going to factor out at least a negative. If it's not, then we'll take a look at what happens at that point. But here, make sure you understand we're going to include the middle sign. Now, step two is we're going to find the GCF of each group. And we're going to do that individually. And then step three is check the leftovers. Here, I'll say it like this. So the binomials must match. So I'm going to say it like this. Binomials must match. And then step four, we're gonna rewrite. So we're gonna say rewrite into binomial times binomial. Okay. So I'll say this again. We're going to group the terms, the first and second term, and then we're going to group the third and fourth term, and we're going to include the middle sign. Then we're going to find the greatest common factor from each group. And then we're going to check on step three. We're going to check to make sure that the binomials must match. So they have to match. And then step four, if they match, then we can rewrite it into binomial times binomial. All right, so let's double check, or let's do an example to see how this works. Excuse me. All right, so our first example, let's try this one. 12x to the third minus 21x squared plus 28x minus 49. Okay. So step one, all right, so step one, I have to group the terms. Well, you can't see it, but group the first and second terms. So I'm gonna put brackets here, and I'm gonna include my sign and put brackets around the second. So 1 and 2, 3 and 4. Now we separated into two different groups. Now I want to find the greatest common factor here. So just ignoring the second the second group, just in the first group, what's the greatest common factor? Well, between 12 and 21, I know the factors of 12, there's a bunch of them. So I'm going to look at 21. What are the factors of 21? Well, the factors of 21 are 3 and 7. Does 7 go into 12? No. So then I look at 3. Does 3 go into 12? Absolutely, it sure does. So I'm going to pull a 3 out. X to the third, x squared. Which one's the smaller exponent? Well, the smaller exponent is going to be x squared. So I'm going to put a 3x squared is going to come out. Now, what's going to be left over? So my division, off on the scratch work, I got to do my division. 12x to the third divided by 3x squared leaves me with 4x. Negative 21x squared divided by 3x squared is a minus 7. And we're done. Now you could do your division off on the side. I'm skipping that for this step. That's something that you can do, and I suggest that you still do it to make sure you're doing this right. Now I'm going to look at the second group. The second group, I have a positive 28x and a negative 49. So I look at this sign, and I'm always going to bring that sign out. What am I going to bring out? Well, between 28 and 49, the factors of 49 are 7 and 7. So does 7 go into 28 evenly? Yeah, it sure does. So I know that I could bring at least a 7 out. Now I have x to the first, and I don't have any x's. So the smallest exponent technically would be 0. So I'm not going to bring out a variable at all. And then 28x divided by 7 is 4x. Negative 49 divided by 7 is a negative 7. So here I have found the greatest common factor in each group. So step 2, find the greatest common factor from each group and bring it out. So I brought the 3x squared out of the first group and the 7 out of the second group. Now step 3, do the binomials match? Now here's what I mean by that. Here I have the 4x minus 7, this binomial, and this 4x minus 7. Are they the exact same? And for part 3, yes, these do. 4x minus 7 does indeed match. So now step 4, I have to rewrite this. So I get 3x squared plus 7 is going to be my first binomial. My second binomial is going to be 4x minus 7. And now I have fully factored by grouping. Let's try one more. Let's try another example here. Let's try 21 x to the third, 21x to the third minus 84x squared plus 15x minus 60. All right, so step 1 is I need to put these in groups. Again, I want to include that sign. If it were a negative, at least I could factor out a negative 1. Hint, hint, if this were a negative, at least I could factor out a negative 1. Just saying. You might even want to write that down somewhere. So if the middle sign is negative, factor at least a negative 1. Alright, so if the middle sign is negative, you can factor out at least a negative 1. Hintity, hint, hint. Okay, so that's step 1, I factored them. Step 2, I need to find the greatest common factor of each group. Well, here with 21 is 3 and 7. 84? Man, I have no idea. Actually, I do. It's a 7. So, whoa, wait. 21's going to come out of both of those. 21 goes into 84 exactly 4 times. So I can bring a 21 out. X to the third, x squared, I get x squared. And what do I have left over? Well, 21x to the third divided by 21x squared is x. Negative 84x squared divided by 21x squared is a negative 4. And then I'm looking over here, 15x minus 60. Well, the 15 and the negative 60, I know 15 goes into 60 because I can tell time. And I know it goes 4 times, so I can bring out a positive, right? Bring your sign. The sign always comes with it. Positive 15. What's going to be left over is x minus 4. Now, do these match? The x minus 4, x minus 4? Yes, those do indeed match. So now I can rewrite my binomials. 21x squared plus 15 times x minus 4. Now you might be looking at this thinking, I know 21 and 15 both have a 3. Well, yeah, we could, and I suggest you bring that 3 out. So we'd be left with 7x squared plus 5, x minus 4. Which tells me I should have thought about pulling out the greatest common factor to begin with. If I had pulled the greatest common factor out to begin with, I would have been in much, much, much better shape. But have no fear, at least I was able to find it eventually. So here, this will be my answer. So just know you can always look for a greatest common factor, but I suggest looking again at the very beginning because that's what I've been harping on this whole time. Let's do one more example. What happens when that middle sign is negative? What happens when that middle sign is negative? Alright, so let's try this guy. Let's try our last example here. Let's go 28x to the third plus 16x squared minus 21x minus 12. Well, a 3 doesn't go into all of them. 2 does not go into all of them. 5, no. And 7, no. Alright, so I got a group here. Include that sign. Include him. Alright, between my first group, 28 has a 7 and a 4. 7 does not go into 16, but 4 does. So I can bring a 4 out. X to the third, x squared. The smallest exponent would be a 2, so I'm going to bring the x squared out. So 28x to the third divided by 4x squared leaves me with 7x. 16x squared divided by 4x squared leaves me with a positive 4. Now, since that sign is negative, I know I have to bring out at least a negative, right? That sign's always going to come with it. So 21 and 12, they both have a 3 in common. And there's no x here, so it's just the 3. 21x divided by 3 is 7x. Negative 12 divided by negative 3 is a positive 4. Do these match? They sure do. So then I can rewrite it. 4x squared. This would be my first binomial. And the second binomial is what matched. And we're done.